In Unit 4. Unit 4, we're going to be doing a ton of work with exponential and logarithmic functions, solving, graphing, and all sorts of different applications. But first, we're going to do something called inverse functions. So today we've got 3 learning targets. Number 1, determining whether or not functions are one-to-one. We'll talk about what that term one-to-one means. Learning target number 2, determine whether functions are inverses, and then being able to write inverse functions and also graph those inverse functions. So first thing, a little bit of vocabulary. Number 1, what does this mean, one-to-one? Well, we'll go ahead and say that a function is one-to-one if, the easiest way to think of it is f of a. If you take f of a and it's equal to f of b, then a equals b. Okay, so if you take this function and you plug in a, and you take the same function and you plug in b, wherever you see the x, then it's going to boil down to a equals b. Now, the converse of this, which is sometimes easier to use, it goes like this. If a does not equal b, then f of a does not equal f of b. Okay, and sometimes this first version is going to be the one you're going to want to use to show that a function is one-to-one. Sometimes the second one is the version that you're going to want to use to show that a function is one-to-one. Now, if both of these are difficult or otherwise impossible, the horizontal line test is probably the easiest way of doing it. So you've heard of the vertical line test to determine whether or not a relation is a function. Well, horizontal line tests is what determines whether or not a function is one-to-one. So if I graphed something like a straight line, well, obviously this passes the vertical line test, so I know it's a function, but it also passes the horizontal line test in a similar fashion. And so yes, this would be an example of a one-to-one function, as opposed to, say, something like a parabola. Well, a parabola does pass the vertical line test, making it a function. It is not one-to-one because it fails the horizontal line test. All right, now inverse functions are something else. So what is an inverse function? Well, an inverse function goes like this. So let's say that we have function f of x, g of x is the inverse function of f of x if f of g of x equals x and g of f of x equals x. So you remember inverse operations, things like the opposite or the inverse of addition is subtraction, the inverse of multiplication is division, and we had inverse properties, that said, like the additive inverse, 5 plus negative 5 equals 0. It gets it back to the additive identity. And, 5 times 1 over 5, the multiplicative inverse, gets you back to the identity. Well, for a function, this is the case. This is the opposite or the inverse. If I take f of g of x, and that boils down to x, and I can take g of f of x, and it also equals x, then these are inverses of each other. G of x is the inverse function of f of x. All right, let's see some examples. We'll start with this one, determine whether each function is one-to-one. So with our function f of x equals negative 4x plus 12, we can do this algebraically. We can go ahead and take a look at f of a. And f of a is going to be negative 4 times a plus 12. And f of b, well, that would be negative 4 times b plus 12. And so if I put these two things together, I wind up with negative 4a plus 12 equals negative 4b plus 12. And the 12s will cancel each other out, and divide both sides by negative 4. Those cancel out, and I get a equals b. So if f of a equals f of b, which I have right here, if a equals b in the end, well, then, yeah, it's 1-to-1. So this checks out. I could also just graph it. I got plus 12 somewhere up here, down 4, to the right 1, down 4, to the right 1. And I could go ahead and graph this out, and if it passed the vertical line test, which it does, then it would also indicate that it was 1-to-1. All right, well here I've got radical 25 minus x squared. So if well, this one actually would be a little bit better to go the other way. Remember I mentioned two ways that we could do this. So if I go ahead and say that a equals 3 and b equals negative 3. And so you can see how this fulfills the second part there. A does not equal b, 3 does not equal negative 3. If I can show that f of a does not equal f of b, well then it would be 1-to-1. So here these two things are not equal to each other. But then I go ahead and plug these things both in. So I got radical 25 minus, we'll do it with a first, 3 squared. Well, that turns out to be the square root of 25 minus 9, which would be 16, which would be 4. And then I'll try it with a negative 3. I got the square root of 25 minus negative 3 squared. Well, negative 3 squared is still positive 9, so I wind up with, again, the square root of 16, which is 4. So this turns out to be, well, the same. And I needed them to be different in this particular scenario, so these don't work. Of course, if I go ahead and try to graph this, what I'm going to wind up with is actually something that looks a little bit like this. And this definitely does not pass the vertical line test. So there's determining whether or not a function is 1-to-1. All right, let's see. Here we've got, is this the inverse of, or is G the inverse of F? So are these two things the inverse of each other? Well, simply we're going to figure out what is F of G of X. And then we're also going to figure out what G of f of x is. If both of these wind up totaling x, well, then they're going to be inverses. And if not, well, then no. So first of all, so I'm going to plug G of x in wherever I see x in f of x. So that means I've got the cubed root of x plus 1 cubed minus 1. So, well, the cubed root, cubed, is, those are going to cancel each other out. And I wind up with x plus 1 minus 1. Well, that's just going to be x. So that works out here, okay, but does it work out here? If I plug in f of x, wherever I see the x in g of x, well, that would give me the cubed root of x cubed minus 1 plus 1. Well, here The cubed root of x minus 1 plus 1 would wind up giving me the cubed root of x cubed. The negative 1 plus 1 would cancel out, and the cubed root of x cubed just winds up being x. And so this works again. And so yes, these are inverses of each other. All right, moving on. Here, kind of a different way of asking whether or not these are inverses. So it just says write and graph the inverse function for this. Well, this function, I could just graph negative 2, 2, negative 1, 1, 0, 0, 1, 3, and then 2, 5. Okay, so there's my relation. You can see that it's a function. It passes the vertical line test. But when I write the inverse function, okay, I'll do this in a different color here. Well, all you need to do, and the whole point of this problem, is that you just switch the x and the y. And so all I would do here is I just switch. I got 2, negative 2. I've got 1, negative 1, 0, 0, 3, 1, and 5, 2. So inverse for function, you're just switching the x and the y. And that gives me 2, negative 2, should be down here, 1, negative 1, 0, 0, 3, 1, and 5, 2. And if you take a look at this, you can almost see a pattern here. If you were able to draw a nice line there representing y equals x, well, you would see that it was symmetric around that point. So that's another big point we're trying to get across here, is that when you have inverse functions, they're going to be symmetric around the line y equals x, that 45-degree angle that cuts through the Cartesian coordinate grid. All right, so let's take this idea and apply it to this. Decide whether each equation defines a one-to-one function, and if it does, find the equation of the inverse. Well, here we do know that 2x plus 5 is a one-to-one function. We could graph it and see that. But let's see, since that's the case, here's how to write the equation of the inverse. First step is we're going to switch the x and the y. So I'm going to turn this into x equals 2y plus 5. Right, so if I were to graph this, I would have the y-intercept at 5. I'd have my slope up 2 to the right 1 or down 2 to the left 1. Okay, and this would give me that line there. Let's see, and then I solve for y. That's going to give me my equation for the inverse. So I subtract 5 from both sides. I get x minus 5 equals 2y. Divide both sides by 2, and I wind up with y equals 1/2 x minus 5/2. And if I were to graph this, so again, I would have a y-intercept at negative 2.5. I'd have a slope of 1/2, so up 1 to the right 2. And you'd have something that kind of looked like this. And you can see that this is perfectly reflected over that line, y equals x. Now, this next one, y equals x squared plus 2, is this going to be one-to-one? Well, if I were to graph it, I would get my parabola, and would that pass the horizontal line test? No. And so this one is not one-to-one. So there's nothing we can do about it. All right, let's go back to this last one here. You've got f of x equals negative, or x minus 2 cubed. So is this one-to-one? Well, let's go ahead and try that trick. Let's plug in a and b and see if things turn out to be the same. So let's see. Let's go ahead and switch the x and the y. So we got x equals y minus 2 cubed. And then I'll take the cubed root of both sides, so that'll give me the cubed root of x equals y minus 2. And then add the 2 to both sides, and I got y equals the cubed root of x plus 2. And so there is the inverse of this function right here. All right, that does it for today. So you got your